Welcome to Module 9, Lesson 3, Order of Operations. Today we're going to talk about how to write expressions in exponential form, and then how to evaluate those expressions in exponential form. But now we're also going to include all the other operations as well. So we're going to talk about what happens when you have multiple operations, including exponents, all in one problem. All right, so we've talked about the order of operations before. And we've all heard about PEMDAS, please excuse my dear Aunt Sally and that. So what I need you to remember is that multiplication and division and addition and subtraction are in their own step. As you can see here, there's actually only 4 steps. Okay, multiplication and division actually happen together, and they work their way from left to right. And we'll talk a little bit about that later when we see those examples. All right, so first let's kind of explore. So we have Amy and 3 friends that launch a new website. Each friend emails the web address to 3 new friends. These new friends forward the web address to 3 more friends. If no one receives the email more than once, how many people will receive the web address in the second wave of emails? All right, so we're going to use this diagram to help us out over here to the right. All right, so each dot represents 1 email. And we're going to complete the diagram to show the second wave. So if Amy sends out an email, all right, she sends it to one person. And then after she sends it to that one person then sends it to 3 more people. All right, so I have Amy sending it to that one person, and then they send it to 3 more people. And then that second person that she sent it to sends it to 3 more people. And then that one person sends it to 3 more people. So now Amy was one person, okay? And she sent it to 3 people. So in the first round, there were 3 emails, which is 3 to the power of 1. In the second round, so here's round 1. In the second round, there were actually 9 emails. And we know that that is 3 to the second power. All right, so what we can do here is we can take a look at this and say, okay, well, I can do Amy plus, because Amy is 1, plus that second, or well, I guess that first wave of people, which is 4. So we can say Amy plus 3 to the first power times 3 to the second power. And that should tell us how many people got the email. Okay, so that should tell us this next round. That should tell us how many people got that email in the next round. Okay? So I know that 1 plus 3 gives me 4. And then I also know that 3 to the second power is 9. And I know that 3 times 9 is 36. So that tells me that 36 people got the email. Okay? So the reason that we use the powers here is because that's hard to keep track of, saying, okay, well, in the first round there was 1, and then in the next round it was 3, and then in the next round it was 9, and then in the next one it was this. So, and then going back and saying, okay, that's 1, 4, and then 4 plus 9 is 13. So it's hard to keep track of that. So if we use powers, it's a little bit easier. And if we use powers, what we can do, and that leads us to the reflection question, if we use powers, what we can do is we can look at how many rounds there were, and we can find the pattern. And in this case, there is a pattern that for each wave, it's an exponent. So for example, the first round would be 3 calls, so 3 to the first. The second round would be 3 callers making 3 calls in each. So in the second round, it was 3 to the second power. So each round would be the exponent. So like in the next round, so if we look at our tree, so again, here was Amy. Girls, enough. So here's Amy, and she sent out that first email to 3 people. So here's 3 to the first. That's how many people got it. Then those 3 people, the dots, sent it out to 3 people. Okay, that would be 3 to the second. Now here, each of these sent it to 3 people. So if we take a look at this, this should be 3 to the third. So there should be 27 people getting this email. So let's count how many people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So the round can be used as the exponent, and the base number, again, that's how many emails are being sent, so that's what's being multiplied by the round, which is the exponent. That tells us how many people, the power tells us how many people got the email in that round. Then if we add those together, that would tell us the total. Or if I just take 4 and multiply it by the last round, so in this case 3 to the third, that would tell me the total. All right. So I know that was a little tough, so let's go back here and let's focus more on the order of operations. So order of operations, again, we said is P for parentheses, E for our exponents, M and D for multiplication and division, and they work their way from left to right, and AS for addition and subtraction. And again, those work their way from left to right. So here I have no groupings, so what I'm going to do is I have no parentheses, no groupings. So for the first round, we're going to ignore that, and we're going to look for exponents. So here I have an exponent of 3 to the second power. So I first have to figure out what 3 to the second power is. 3 to the second power means 3 times 3, which is 9. So I bring everything else down that I haven't used. I bring down the 5, I bring down the plus 18 and the division, and then I bring down 9. Okay? Then what I do is I go through and I figure out the next step. Multiplication or division. In this case, I have division. So 18 divided by 9 is 2. I have 5 and I have plus left. And then the only thing left to do is add. So my answer here would be 7. All right. Now I'm going to go back. So I'm going to go to B. I'm going to check, do I have any exponents? I do. My exponent in this case, my exponential problem is 3 squared. So I still have 21 plus 3 squared in this case is 9. And I'm dividing that by 3. Now I know sometimes leaving this in fraction form is confusing. So another way that you can look at this is by writing it like this. 21 plus 3 squared divided by 3, which then would become 21 plus 9 divided by 3. Okay, do I have any more exponents? I do not. So I can do multiplication or division. In this case, it's division. 9 divided by 3 is 3. Bring down the plus and the 21. 21 plus 3 is 24. So my answer is 24. The biggest caution I give you is that students really like to skip steps or try to do all of this in their head, and then they miss something or they do something in the wrong order, and it's really hard to help you go back. Show your work and do one step at a time. Don't try to do too much at once. I cannot stress this enough. All right? So here we go. So now in C, I have an exponent. In this case, it's 2 to the third power, which means 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Okay, bring down everything else that I haven't used. 6 times 8 divided by 3 plus 1. 6 times 8 would be next because it's multiplication and division. And I work my way from left to right, and multiplication came first. So that's 48 divided by 3 plus 1. I have 48 divided by 3. 48 divided by 3 is 16. 16 plus 1 would give me 17. Right. And I'm going to go ahead and apologize for the crazies in the background. All right, so what you're going to do is I want you to, if you don't have enough space, grab a separate sheet of paper and do it on a separate sheet of paper and then put it into the notebook later. But I want you to pause the video and then try these, and when you come back, we'll check your answers. All right, so you should have gotten 1,222 and 170. In this case, it should have been 7 plus 15 times 81. Okay, 15 times 81. Well, 81 times 10 would have been 810. And 81 times 5, well, let's do it this way. So 81 times 15, 5 times 1 is 5, 8 times 5 is 40, 0, 1 times 1 is 1, 8 times 1 is 8. My brain is not working well for mental math today, so we're going to do traditional. So I get 7 plus 1,215, and then I add 7 plus 1,215, and I get 1,222. Now, yes, you can use a calculator for this, but you still have to show all of your steps. Here I got 222 minus 450 divided by, what you should have gotten here was 9. Okay, 450 divided by 9, I do 45 divided by 9 is 5 with 1 0. 220 minus 50, in this case, would give me 170. All right, so now what we're going to do is now we are going to include those parentheses. So we'll have parentheses, we will have exponents, we will have multiplication and division, and I just drew 2 multiplication signs, and we will have addition and subtraction. Okay? All right, so now here's what's really important to understand. You have to look at what's happening within the grouping. You have to do what's inside the parentheses first and then what's outside. So in this case, what's inside the parentheses is 9 divided by 3. And on the outside is the exponent. So what it's saying is, I want 9 to be divided by 3, and then I want the answer to that to be squared. So I don't want to use the 4 yet. I don't want to use multiplication, but I want to do 9 divided by 3. 9 divided by 3 is 3. And so that's what I want to square, because that's the answer to 9 divided by 3. So it's like when we talked about the fraction and all of it being squared, because everything inside of the parentheses is being squared. Okay, well, everything inside of the parentheses is being squared, but after the operation is performed. All right, so here 9 was divided by 3. And now we can square it, and we get 4 times 9 which gives us 36. All right. So then now on the next problem, we have 5 cubed plus the quantity 12 minus 2 squared. So again, I have to do what's inside the parentheses first. I have to do 12 minus 2 first, and then that answer is what's being squared. So I have 5 cubed plus 10 is what I get when I subtract 12 minus 2. And that is what I want to square. 5 cubed means 5 times 5 times 5, which I know is 125. Now I can do both exponents at once because they're both exponents on their own. So I can do 125 and do 10 squared, which is 100. And I know 125 plus 100 is 225. All right. All right. Now, this is where it gets interesting. I know that this is in parentheses up here, but it's in parentheses because it's being squared. If this wasn't in parentheses, because of the fact that it's written like a fraction, you would have to do the 12 minus 8 before you divide it by 2. Because what it's saying is it wants the answer of 12 minus 8 to be divided by 2, not the 8 itself. And we can talk more about that when we look at some other problems. All right, but in this case, I have to do the parentheses first. So I have 8 plus 4 squared divided by, oops, that all shouldn't have been divided by. That's my fault. Drew my line a little bit too long there. Divided by 2. So now I have 8 plus 16 divided by 2. 16 divided by 2 is 8. So I have 8 plus 8, which gives me 16. All right, so let's take a look at the next question. This goes along with the parentheses and that being squared. So John wants to simplify the expression 5 plus 3 all taken to the second power. Notice that the squared is on the outside. As a first step, he decided to distribute that squared and share it with the 5 and with the 3. Will he get the correct value for the expression? If not, what should he do to simplify the expression? Okay, so I want you to think about this. Will he get the correct answer? If you're not sure, take a minute and solve it the way that we would solve it, and then solve it the way that John set it up and see what happens. All right, you should have come up with the fact that he would not get the correct answer. And the reason that he would not get the correct answer is because of the fact that if you actually map it out, 5 squared is 25, plus 3 squared is 9, which only gets you to 36. Okay, that only gives you 36. Whereas if he were to add the 5 to the 3, like he's supposed to, so to do 5 plus 3, that gave him 8, and square that, he would have gotten 64. But what he did gave him 25 plus 9, which only gave him 36. This is why the order of operations is so incredibly important. Because if we don't follow them, we come up with the incorrect answer, which in a lot of jobs makes a huge difference. In some cases, it's the difference between life and death. In some cases, it's the difference between having a door you can walk in and a door you can't. Or a building that stands and a building that doesn't. All right, so now you have the opportunity to try these problems on your own. And again, pause, and when you come back, we'll check your answers. All right, so here we go. You should have gotten 125, 15, and 0. For number 5, you should have gotten that 20 divided by 4 was 5. And when you square it, you got 25. And then when you did 5 times 25, you got 125. Then here, you should have gotten that 8 squared minus 5, you had 5 plus 2 is 7, which had to be squared, which was 49. 8 had to be squared, which was 64. 64 minus 49 gave you 15. This next one was kind of fun. You had to do 63 divided by 9, which gave you 7. But then you had to square 7, which gave you 49. And then you had to take 49 and divide it by 7, which gave you 7. And then you had to do 7 minus 7, which gave you 0. All right. So now what I would like you to do is you're going to do your guided practice, but remember we're doing them on Go Math. You can also do the problems that are in your packet for extra practice. And as always, if you have any questions, please be sure to write them down or email me so we can go over them in class.